Hello there. We are Team Cars. My name is Reed. Other members of the group are Reagan, Greta, and Carter. And our main topic that we're going to be focusing on this semester is to limit hard braking. So as you can see here, this is our single car simulation setup. All of the different little functions on the screen are different controls we use to run different types of simulations. If we dive in here, we can see the actual single car simulation that we have. So here's our single car. And then here is going to be our acceleration function. So we have different inputs such as the time gap flag, space gap flag, preferred acceleration, time gap, space gap, and velocity. The idea there is when we are too close, so our time gap is too small between a car in front of us or behind us, we want to decelerate at the specific preferred acceleration. And we have different things like space gap flag and space gap to help account for different situations where kind of edge cases where the time gaps is not necessarily adequate in order to determine our acceleration. Finally, I just wanted to quickly show you the multi-car simulations we have set up here. So here's the ego car, the lead car, and again, the acceleration function that we have. And then we have different options to input values to control kind of the simulation we're hoping to test.
Okay, so our first test looked at just manipulating our initial velocity, but keeping these two parameters the same. And you can see that our car would hit our maximum acceleration of 1.5 meters per second squared. And then once that space gap was getting close to a time gap of just about 3 seconds, it would decelerate decently sharply, but at least it got a little bit more of a slow, quick acceleration, and then back down to a steady deceleration. And it behaved in a similar way for when it was at the maximum initial velocity it could be. It's ever just decelerated faster. And then when it was at 0 meters per second for the minimum, it remained at the same acceleration of 1.5 meters per second squared because that's the max. It was just in our time frame. And these were consistent with our prediction. Another simulation I wanted to talk about is when we cut the space gap of the lead car from 20 to 0 at 10 seconds, which you can see happens right here. Our car is decelerating because the space gap was only 80, and then it does a quick deceleration and then an even faster one. And then once the headway is recovered, it remains steady. And so this was a great example for us. The last simulation I wanted to look at was our stop and go simulation. It's where I set our pulse generator to have a period about every 10 seconds, and the lead vehicle is going to move from 0 to 5 meters. And I wanted to deal with how we look at in smaller speeds, and it's really a good result because our ego car is not nudging forward when the lead car is stopped, and it's not creeping, and it also still moves forward when the lead car goes, creating this oscillatory wave, and it's right around 0, so it's really good.
We checked under conditions like where the lead vehicle is stationary, if we ever go in reverse, which yes we do. The lead car speeds away, essentially increasing the space gap, shows that we have a maximum acceleration value and that we won't really accelerate to an extreme value. We also checked if we would cap our velocity, and we haven't exactly done that yet, so no, we have not. We wanted to also check how the car would react to a vehicle that's speeding up and slowing down. And that's exactly that. We handle it quite well. We don't exactly get a crash, but we do get kind of close, so we might want to put a little bit of a margin. And we also checked for how we would transition between phases, and essentially like we can see a lot of like low acceleration, no acceleration, our preferred acceleration. We haven't exactly exceeded that acceleration value, so that's our maximum acceleration. But yeah, it shows a pattern of behavior where we oscillate between different acceleration values. We also checked where we would introduce a new vehicle. Essentially, I would just put the two in extreme close proximity at the beginning. And yeah, we can see like we have a very big deceleration, which shouldn't exactly be like that, so we do need to fix that. And this is our space gap graph where we begin at 0, and that's where like we need to really accelerate, and that's what our controller is saying. And we also wanted to check the open road, and I just essentially put the ego vehicle in front of the lead vehicle at the beginning, and we can see that it just sort of stably increases speed, but it oddly does not, it maximizes, or it has like a limit to its velocity, which is very interesting, so we'll have to look into that.